Today, we'll focus on HPLC assay calculations using a practical training example based on acetaminophen API. It's essential that all method data is carefully verified against the approved standard operating procedure, certificate of analysis, and the relevant calculation worksheet to ensure accuracy and compliance. This session is designed as a hands-on guide walking you through preparing standards, calculating concentrations, evaluating system suitability, and ultimately reporting assay results. By working through this example on acetaminophen API on a dried basis, you'll gain a clear understanding of each step in the process. Remember, always refer to the approved documents as your source of truth throughout any assay work. In this training, we'll focus on HPLC assay calculations using acetaminophen as our example API. First and foremost, all method data must be carefully verified against the approved standard operating procedure, certificate of analysis, or worksheet to ensure accuracy and compliance. Our learning objectives are designed to build a clear and logical approach to calculations that are traceable and can support quality control decisions. You'll learn to prepare a potency-corrected stock standard by converting the certificate of analysis potency into a decimal and calculating the actual concentration, which we refer to as CS. Next, we'll cover how to design a working standard dilution using the formula C1V1 equals C2V2. This will help you confirm whether the volume transfer during dilution is practical and appropriate. We'll then move to calculating the sample concentration on a dried basis, applying the actual sample weight, final volume, and adjusting for any loss on drying to determine CU accurately. Finally, you'll understand how to turn raw HPLC peak areas into a meaningful assay result. This includes checking the relative standard deviation percentage to assess precision, calculating mean responses, applying the assay equation, and properly documenting the final disposition. Remember, while this training example uses an acetaminophen assay framework, it's important to note that it's for educational purposes and does not replace the validated analytical procedure used in your laboratory. On this slide, we're focusing on the critical workflow for HPLC assay calculations using acetaminophen as our training example. The main principle here is maintaining one clean path from the raw inputs all the way through to the release decision. This means every piece of data and calculation must be traceable and verified against approved documents like the SOP, certificate of analysis, or worksheet before any map begins. First, we start by confirming the method and COA details. This includes checking the approved SOP, understanding the method's target, basis, acceptance criteria, and the reference standard's potency. Accuracy at this stage sets the foundation for everything that follows. Next, we prepare the standard solution, carefully recording the actual weight of the reference standard, the final volume, the diluent used, and the potency factor. Precise recording here ensures the standard concentration is correct, which is critical for reliable results. Then, we move to sample preparation, documenting the sample weight, all volumes and aliquots involved, as well as loss on drying or moisture content. These details are essential because they impact the final assay calculation and quality assessment. Once the samples are ready, we run the HPLC with an approved integration method. It's important to check system suitability and injection precision to confirm the system is performing properly and the results are consistent. Finally, we calculate and review the assay using the formula. The ratio of the sample area to the standard area multiplied by the ratio of the standard concentration to the sample concentration, all multiplied by 100. It's crucial to round only once after the calculation, and then assess the result against acceptance criteria. Throughout this process, the key takeaway is to prioritize traceability before jumping into calculations. This ensures accuracy, reliability, and confidence in the assay results. Here, we're focusing on the HPLC assay calculations using acetaminophen as a training example. It's crucial that the method data we work with is verified against the approved standard operating procedure, the certificate of analysis, and any relevant worksheets to ensure accuracy. Before performing calculations, all method requirements must be locked in to maintain consistency. Our reference method includes a standard solution of 0.1 milligrams per milliliter of USP acetaminophen reference, standard in methanol, and a sample solution prepared at the same concentration in methanol. The assay calculation uses the ratio of the response of the sample to the standard multiply by the ratio of the concentrations, then multiply by 100 to get the percentage. Acceptable assay results fall between 98 and 102% on a dried basis, ensuring product quality. Additionally, the standard solution's percent relative standard deviation should be no more than 1%, confirming method suitability. These guidelines are based on the official acetaminophen assay method dated May 1st, 2014, so always make sure to use the current approved method in production. Now let's look at HPLC assay calculations using acetaminophen API as a training example. The first and most crucial point is ensuring input integrity. Before we start any calculations, it's important to have the right inputs. No matter how advanced our tools are, whether AI, spreadsheets, or manual methods, if the initial data wasn't captured correctly, we can't fix the results later. We start with a governing reference, which means verifying the SOP or monograph title, including its revision and page numbers. This ensures we're following the correct procedures. We also need to confirm the required basis and acceptance criteria, along with details about the diluents and target concentrations. For standard preparation, it's essential to record the reference standard's name, lot number, and its potency as per the certificate of analysis. Additionally, carefully measure the actual weight of the reference standard and the final volumes prepared in. Keep in mind any potency basis or correction factors that apply. When preparing the sample, the actual sample weight must be documented. All dilutions and aliquots used during the preparation process need to be recorded precisely. If there's a loss on drying or moisture content, we calculate the dry fraction to account for this in our results. Finally, in chromatography, we collect the individual areas of standards and samples and calculate the approved mean response. We also apply blend corrections and confirm system suitability to ensure the run is valid. These steps collectively help maintain accuracy and compliance throughout the assay calculation process. Here we focus on HPLC assay calculations using a training example with acetaminophen API. The first critical step is to prepare the potency-corrected stock standard solution. It's important to understand that the nominal target concentration is not always the actual concentration. Instead, we use the actual weight of the reference standard and adjust it according to its potency as specified on Certificate of Analysis, or COA. The core equation we use to calculate the standard solution concentration is C sub S equals W sub S multiplied by P divided by V sub S. Here, W sub S represents the actual weight of the reference standard. P is the potency from the COA, expressed as a decimal, not a percentage. V sub S is the final volume of the volumetric flask in which the standard is prepared. Putting it together, this calculation gives us C sub S, the actual concentration of the standard solution. One important rule to keep in mind is that all calculations should be done with full precision. You only round off the values when reporting the final concentration, and this rounding should follow the guidelines specified in the SOP. Finally, always verify your method data against the approved SOP, COA, or worksheet to ensure accuracy and compliance. Here, we're working through an HPLC assay calculation using acetaminophen as our training example. It's important to start by verifying all method data against the approved SOP, Certificate of Analysis, or worksheet to ensure accuracy. In this standard preparation example, we aim to prepare a solution with a concentration around 0.100 milligrams per milliliter, taking into account a potency correction of 98%. The reference standard weight used is 10.204 milligrams, and when adjusted for the 98% potency, this accurately reflects the amount of active ingredient. We dilute this in 100 milliliters of methanol as the solvent. The calculation for the concentration, C, is straightforward. Multiply the weight by the potency, then divide by the volume. This gives us roughly 0.100 milligrams per milliliter, which matches our target. To confirm, an independent check multiplies the concentration by the final volume, yielding an active equivalent very close to the potency-corrected weight. This consistency validates our preparation. Finally, always document the actual weight, the Certificate of Analysis potency, and the basis for potency used in your calculation. Don't just record 0.1 milligrams per milliliter, without the supporting details, as having the exact values is crucial for reproducibility and regulatory compliance. Now, let's talk about the dilution design step in our HPLC assay calculations, using acetaminophen API as an example. The key here is to prepare a working standard by dilution, following the formula CV equals C2V2. This ensures that the concentration and volume of the stock and working solutions are properly balanced. Always verify your method data against the approved SOP, COA, or worksheet to maintain accuracy. For instance, if our stock concentration, C, is 100 micrograms per milliliter, and we want a working concentration, C2, of 20 micrograms per milliliter with final volume, V2, of 50 milliliters, we solve for V. Plugging in the numbers, V comes out to 10 milliliters. So we'll transfer 10 milliliters of the stock solution and dilute it up to 50 milliliters to get our working standard. One important practical note. If V is smaller than the minimum volume your lab can accurately measure, don't hesitate to prepare an intermediate dilution to maintain precision, rather than try to measure an impractically small volume. This step is crucial to ensure reliable and reproducible results. Now, let's focus on calculating the sample concentration on a dry basis using our acetaminophen API example. First, it's essential that the method data are verified against the approved standard operating procedure, certificate of analysis, or worksheet to ensure accuracy and compliance. To begin, we calculate the dry fraction, which accounts for the loss on drying. This is done by subtracting the loss on drying percentage divided by 100 from 1. In our example, with a loss on drying of 0.2%, the dry fraction is 0.9980. Next, the sample concentration, represented as C, must take into account the actual sample weight, the dry fraction, the final solution volume, and any dilution factors. The formula we use is C equals the sample weight multiplied by the dry fraction, divided by the final volume, and then multiplied by the dilution factors. For our sample, the weight is 10.020 milligrams, and the final volume is 100 milliliters. Applying these values, the calculated concentration comes out to approximately 0.0999996 milligrams per milliliter. It's critical to perform a final check to ensure that any aliquot taken is not larger than the volume of the solution itself, maintaining the integrity of the calculation and the assay. This step prevents errors in quantitation and helps maintain consistent, reliable results. Here we're focusing on the critical step of converting chromatographic peak areas into mean responses for an HPLC assay, using acetaminophen as a training example. First, it's essential to verify all method data against the approved standard operating procedure, certificate of analysis, or worksheet to ensure accuracy and compliance. Notice that only the injections allowed by the data review process are used for calculations. We calculate the mean response of standard injections, which here is approximately 500,033.33, representing a consistent and reliable measurement across 6 injections. Similarly, for the sample injections, the mean response is 497,533.33, calculated from 3 injections. These mean responses provide the basis for applying the assay equation in the next steps, enabling precise quantification of the acetaminophen API in the sample. This process highlights the importance of careful data verification and averaging before moving forward in assay calculations. In this slide, we're focusing on the importance of system suitability in HPLC assay calculations using acetaminophen as our training example. Before interpreting any assay results, it's critical to verify the method data against the approved SOP, certificate of analysis, or worksheet to ensure accuracy and compliance. Step 5 highlights the need to check injection precision prior to reporting results. Even if the assay calculation itself is mathematically correct, it cannot be considered valid if the chromatographic system fails the predefined suitability criteria. Looking at the standard area spread data, you see a series of 6 injections with peak areas close to 500,000. The calculated percent relative standard deviation, or percent RSD, is just 0.022%, which is significantly below the method limit of not more than 1%. This excellent precision confirms that the system is performing properly. Only after confirming that the system suitability criteria are met should we use the mean standard area for further calculations. This step ensures the reliability and integrity of the assay results before they are reported. Now, let's focus on step 6, which involves applying the assay equation in HPLC assay calculations, using acetaminophen as our example. It's crucial that all method data you use is verified against the approved standard operating procedure, certificate of analysis, or worksheet to ensure accuracy. The assay result itself is calculated by combining two key ratios, the chromatographic response ratio and the preparation concentration ratio. The formula we use is assay percentage equals the ratio of the mean peak response from the sample solution to that from the standard solution, multiplied by the concentration of the standard over the concentration of the sample, all multiplied by 100. Here, our sub U represents the mean peak response of the sample, while our sub S is that of the standard. C sub S and C sub U are the actual concentrations of the standard and sample solutions, respectively. An important point to remember is that if the standard and sample are prepared at the same concentration, the ratio C sub S over C sub U should be approximately 1. However, never assume this ratio is exactly 1 because factors like CoA potency, limits of detection, actual sample weights, or varying dilutions can affect it. Paying close attention to these details ensures precise and valid assay results. Now, let's put it all together with a worked example for the HPLC assay calculation of acetaminophen API. It's important to remember that all method data must be verified against the approved standard operating procedure, certificate of analysis, or worksheet before proceeding. In this example, we use actual calculated concentrations and mean peak responses, not just nominal values. The mean sample response, denoted as our sub-U, is 497,533.33, and the mean standard response, our sub-S, is 500,033.33. The actual standard concentration, C sub S, is 0.0999992 milligrams per milliliter, while the actual sample concentration, C sub U, is slightly different at 0.099999 6 milligrams per milliliter. The assay calculation formula is the ratio of the mean sample response to mean standard response, multiplied by the ratio of the actual standard concentration to the actual sample concentration, all multiplied by 100 to get the percentage. When we plug in our numbers, we get an assay of 99.4996%, which is rounded to 99.5% according to the approved worksheet rules. For reporting, the assay result is described as 99.5% on a dried basis. This falls within the acceptance range of 98.0% to 102.0%, so the sample passes the assay test. Remember that rounding is only done once, after all calculations are completed, to ensure accuracy and compliance with the standard procedures. Let's talk about common calculation errors in HPLC assays, especially using acetaminophen as an example. First, it's crucial that all method data is verified against the approved SOP, certificate of analysis, or worksheet before proceeding. Now, most assay errors aren't due to complex math, but usually stem from unit mix-ups, incorrect inputs, or misalignment with the method. One frequent mistake is using the nominal concentration instead of the actual concentration of the standard. Always use the actual reference standard weight multiplied by its potency, divided by the final volume to get an accurate concentration. Another common error is missing a dilution step. To avoid this, record each aliquot and final volume as separate factors to ensure every dilution is accounted for. Sometimes, problems arise from misreading moisture content or loss on drying values. It's important to confirm whether your result reflects percent moisture, percent LOD, dry matter, or another basis before using it in calculations. Then, there's the issue of using failed standard injections. Never calculate with areas from injections that have not passed suitability tests. These data points can lead to incorrect results. Rounding too early in calculations can also cause errors. Keep full precision in your worksheet and only round the final reportable result to maintain accuracy. Finally, watch out for impossible transfer volumes. An aliquot volume should never exceed what's available in the source solution. Paying attention to these common pitfalls will help ensure your assay calculations are accurate and reliable. This slide focuses on how AI can assist with HPLC assay calculations, using acetaminophen API as an example. It's crucial that all method data be verified against the approved SOP, certificate of analysis, or worksheet to ensure accuracy. AI can serve as a helpful calculation checker by structuring the calculations, flagging any missing inputs, and clearly showing the math involved. However, the SOP and a qualified reviewer must always guide and control the process. When using AI, you start by providing specific prompt inputs such as the SOP title, revision number, section, and page, along with details like required standard and sample concentrations, RS weight, certificate of analysis potency, sample weight, volumes, moisture content, peak areas for standards and samples, and the rounding rules and acceptance criteria. In response, the AI outputs several key steps. It restates the method requirements, asks for any missing inputs, calculates concentration CS and CU, checks dilution logic, computes mean areas and percent relative standard deviation, and finally, shows the full assay calculation. It's important to remember that AI should never be used to create new method requirements, justify excluded injections, or approve results. These decisions must always be made within the quality system framework by trained personnel. AI is a tool to support accuracy and efficiency, not to replace professional judgment. On this slide, we're focusing on conducting HPLC assay calculations using a practical example with acetaminophen API. The key point here is that before we start any calculations, it's essential to verify all method data against the approved SOP, certificate of analysis, or worksheet. This ensures accuracy and compliance throughout the process. The prompt encourages a thorough and disciplined approach. You're asked to act as an HPLC calculation checker, relying solely on the data provided, without making assumptions. This means you need to confirm several critical details up front: the exact SOP or method title, revision number, the section and page of the method, reporting basis, and acceptance criteria. This establishes the framework for the calculation. Next, you must request specific inputs: reference standard weight, potency and its basis in the COA, final standard volume, sample weight, all aliquot volumes, loss on drying or moisture content, individual peak areas for standards and samples, any blank corrections, and the approved rounding rules. The calculation steps include determining the concentration of the standard solution, C, the concentration of the sample, C, incorporating dilution factors and dry basis corrections where needed. You then calculate the mean response ratios for standards and samples, R and R, the relative standard deviation to assess precision, and finally, the assay percentage itself using the formula provided. A crucial part of this process is transparency, showing every equation used and including units. Also, you need to flag any missing information, unsupported assumptions, unit mismatches, errors in volume transfers, or any failure of the method suitability. The results should never be deemed compliant unless all method criteria and approved data are present and verified. This approach ensures that HPLC assay calculations are both accurate and reliable, minimizing errors and maintaining compliance with quality standards. Now, let's focus on the quality review step in HPLC assay calculations, using acetaminophen API as an example. It's essential that the method data is thoroughly verified against the approved standard operating procedure, certificate of analysis, and worksheet. Before reporting, we use a final reviewer checklist to ensure everything is accurate and complete. This final review screen is crucial before transferring any result to the official record or certificate of analysis. Key points include confirming the method, SOP, and reporting basis are correct. We verify the identity, certificate of analysis, and potency of the reference standard. We also check the actual weights used for both standards and samples. Every dilution or aliquot must be accounted for and physically possible, with LOD or moisture corrections applied only when necessary. Standard and sample peak areas need to be approved, and we must ensure system suitability and integration reviews are accepted. Precision is maintained until the very end, when final rounding occurs. The final result is also compared against acceptance criteria to confirm it's valid, where required. An independent review is completed to add an extra layer of assurance. Remember, the calculation process is only truly complete once this comprehensive data review is finished. Let's review the key points for HPLC assay calculations using acetaminophen as our training example. First, it's essential to verify all method data against the approved SOP, certificate of analysis, or worksheet to ensure accuracy and compliance. The most important takeaway here is to build your result from traceable inputs. This means using actual weights, actual concentrations, and method-approved correction factors without shortcuts. Before you use chromatographic peak areas in your calculations, always check system suitability to confirm the system is performing correctly. Every dilution step must be carefully documented, and avoid rounding values until the final result is reported to maintain precision. Also, recognize that artificial intelligence tools can serve as independent checkers, but should never replace the official SOP, quality assurance reviews, or final release authority. Finally, remember to reference your sources. This training included guidelines from the acetaminophen revision announcement from 2014. Always follow the current approved method and laboratory SOP. Thank you for your attention.